We're going to look at a couple of examples using the gradient formula. And the two examples, one, you're given 2 points and you're asked to find the gradient, y-intercept, and then the equation of the line. And the second example uses basically a set of points given in a table of values, and you're asked to find the equation of the line. So example A, a bit more scaffolded, okay, a little bit easier to answer, because you're basically told step by step what to do. Example B, there's no scaffolding at all, you're just given a table of values and asked to find the equation. If you like, you can pause the video at this point, give this question a go. Okay, basically the end result is like the equation of the line that passes through these 2 points. Okay. Once you're done, if you want, unpause the video, watch the work solution. All right, so I'm going to go through the solution now with you. So first of all, we're going to determine the gradient of the line. Okay, there's 2 points there. Okay, now you might want to think first of all which point comes before the other, but in actual fact it doesn't really matter. The x values, this point here, -1, 5, is actually on this side. Okay, and 3, 7, okay, so I'll just fill this, 3, -7 is actually a point on the right hand side of the coordinate plane, but -7, so it's actually down, okay, under the x-axis. That actually doesn't really matter. All you need to do is just label these points. And as long as you use the formula correctly using the correct labels, and it doesn't really matter which one you label, as long as the x1 and the y1, the x2 and the y2 stay together. That's the key. So let's do that. Okay, so let's call that x1. Okay, this one is x2. This -7 is y1. The 5 here is y2. So notice that the x1, y1 must stay together. x2, y2 must stay together. Now we can use the gradient formula, or the sometimes it's called the 2-point formula because we use 2 points, right? So m, okay, is equal to y2 minus y1 over x2 minus x1. I could label these the other way around and it actually wouldn't matter. The formula is still the same, and you actually get the same answer every time. So as long as the pairs stay together, the correct pairs stay together, x1, y1 stay together, x2, y2 stay together, then the formula will work either way. All right, so y2 minus y1, so y2 is 5, minus y1, that's -7. Okay, so notice the double negative there. 5 minus -7. Okay, slight difference between the word minus and the word negative. We're actually subtracting a negative number. Well, you know what a double minus does, right? And it turned it into an addition. All right, x2 minus x1. So x2 is -1 minus x1, which is 3. -7 is 12. -1 minus 3 is -4. Now, while the run typically is positive, because I've actually swapped the points around, okay, the runs now become negative. It doesn't actually matter at all. In fact, the gradient, the end result is that the gradient that you calculate will still be correct, okay? If you swap those points around, so x1, y1, make -1, 5x1, y1, and make 3, -7, x2, y2, what do you think is going to happen? What happens is that the 12 becomes a negative and the 4 becomes positive. So this will become a positive 4, this becomes -12. You still get the same answer in the end, which is -3. So the gradient's -3. So how do you describe a gradient aligned with gradient -3? A fairly steep downhill, isn't it? Sort of looks like that, doesn't it? Okay. For every point across, okay, every point across, we go 3 points down. Okay, so a fairly steep downhill. Okay. Next, determine the y-intercept of the line. Okay, now we know that the equation of the line is of the form y equals mx plus c. Great, we know this, there's nothing unusual there. We're going to rearrange this equation because we want the plus c, that's the y-intercept. So let's move the mx over to the other side. Okay, so move it over to the left-hand side. So the mx is well, it looks like a positive. Well, let's sort of do the opposite there, just make it a negative. Y minus mx, so subtracting mx from both sides, is equal to c. Now we need to pick a point. We need a y value and an x value. We know what m is. M is -3. Okay. Go back to the original question. Okay. let's, it doesn't really matter which point you choose really. Let's pick x2, y2, only because the numbers are smaller. They both have negatives in them, so we're not going to escape the negatives. So y minus mx, okay, so y is 5, okay, minus mx, what's m? Okay, this is our m, okay, that's our m there. So negative 3 multiplied by x, which is negative 1, okay, times negative 1, which equals c. Right, so BIDMAS takes over here, negative 3 times negative 1, okay, that's positive 3. Okay. And c is equal to 2. Okay, hopefully we're in agreement there. So we've got a gradient of negative 3 and a y-intercept of positive 2. So the last part is, okay, to find the equation of the line for 1 mark. Okay, the other two are probably worth, if you ask me how many marks would they be worth, probably 2 marks for that one, I'd say. I mean, 1 mark for the sort of the using the formula and a mark for the answer, of course. And probably this one here, 2 marks would be most appropriate. Again, 1 mark for rearranging the formula and sort of knowing, okay, I've got to rearrange it, and then obviously a mark for the correct execution of this and to get the value of c equals c equals positive 2. All right, 1 mark now. Now you just use what you've found. Okay, so we know that y is equal to mx plus c. All right. So the equation will be y is equal to, the m was what, negative 3, okay, x, and the c was, or the y-intercept, positive 2, okay. You could be asked to graph this, and if you were asked to graph it, what would it look like? Of course, you'd need to use some sort of grid paper, but if you had to graph it, okay, somewhat to scale if you had to, but it doesn't really matter, okay. Always mark in, okay, draw these with a ruler, the axes, mark in the labels for the axes, so the x and the y, okay, always a good habit to get into. Mark in the origin. I've just marked in here the y-intercept of 2, and we want a gradient of negative 3, okay, so as long as it's a negative, okay, something like that, and I would just, okay, you've quoted 1 point there, I would quote a second point somewhere, just label a second point, and one of the other points was 3, negative 7, so I could use that somewhere on the line as well, and I could put that here, okay, and 3, negative 7. So as long as you've got 2 points, it doesn't matter whether it's drawn to scale or not, as long as you've got 2 points and they're correct points on the line, there's only one line that can pass through that, okay, and that is the line, I might just label this, that's y is equal to negative 3x plus 2. All right, time for example part B. Okay, so this is unrelated. All right, have a read of that question. Find the equation of the line represented by the following table of values. All right, so we've got four coordinates here, right? X coordinate, Y coordinate, 4 different points. You can use any point you like. I'm not scaffolding this at all. If you want to, you can pause the video, give this a go. What I want is the equation of the line. All right, so hit pause now. Okay, probably unpause the video by now. Let's go through the work solution. I want the equation of the line. Equation of the line, you need 2 things. Okay, first of all, 3 things really. First thing, you need to know that it's going to be in the form y equals mx plus c. The next thing you need is the m. Okay, you need the gradient of this line. Okay, so let's determine the gradient first. All right, determining the m. Pick any 2 points you like. Any points, whatever, the most convenient points. You know what? I'm going to pick this point here, okay, and I'm going to pick this point there. And because 0 is a nice number and sort of doesn't do anything, right? When you add it, it doesn't do anything. When you multiply by 0, it gives you 0, so it's a nice one to pick. And 8, 8, yeah, nice numbers there. Nice sort of integers there. I wouldn't pick the fraction. Again, just complicates things unnecessarily. Any 2 points, doesn't really matter. Let's make this one x2, y2, and this one x1, y1. How about we do that? All right. So we're going to let x1, comma y1, all right, be 0, negative 4, and we're going to let x2, y2 equal 8, comma 8. So m is equal to y2 minus y1 over x2 minus x1. So y2 minus y1. So there's your y2 minus y1 there. All right. So it's going to be 8 minus negative 4 over x2 minus x1. Okay. So it's going to be 8 minus 0. Okay. Let's see what we get there. 8 minus minus 4, that's 12 over 8. And we're going to get an improper fraction here. Okay, so 12 over 8. Okay, if you divide top and bottom by 4, you get 3 over 2. So this is that's our gradient. Okay, it's actually 1.5 or 3 on 2. So for every for every 2 we go across, we go 3 up. For every 2 we go across, we go 3 up. Okay, so that's a gradient of 1.5. All right, now we need to determine the y-intercept. How are we going to do that? Recall, what do we do with the formula? I want the c. I've got the m. I can find any x and y value that's convenient. There are plenty of them there to pick from in the table of values. We're going to rearrange the gradient intercept formula of the line, aren't we? Okay, so use a different color here. So what I'm going to do is I'm going to determine, right, the c. And we're going to rearrange this formula. So y minus mx is equal to c. Okay. Pick a nice point. You know what? Let's pick 8, 8 again. I just like those two numbers. Just nice, easy to work with. Both positive numbers, no fractions. Great. So we've got a y value of 8. Okay. So I might just save a bit of space. 8 minus mx. So that's 3 on 2 times, okay, x is 8, so we're using this point here, 8, 8, okay, is equal to c. Okay, so 8 minus, what's 3 on 2 times 8? 1.5 times 8 is 12, okay, is equal to c. Therefore, c is equal to negative 4. Okay. So we now have our two important critical values. We have our gradient. We now have our y-intercept. So what's the equation of the line? Okay. Combine the two together. Okay. Right. I like to write down the general equation first and then substitute in what we need. The gradient is 3 on 2. And the y-intercept was, just confirm, negative 4. Okay. And that's it. Done. Okay. Now, you might think, how do I know I got the answer right? One last little thing. Can we check this to ensure that this equation is correct? How do we do that? Let's pick another point. Let's pick the point negative 2, negative 7, and see if this holds true. Okay, so last thing we're going to do now is we're going to do a check. Okay, we're going to check that the coordinate or the point negative 2, negative 7 lies on this line. How are we going to do that? We're going to check left hand side, check right hand side. Okay, so left hand side, y is in fact equal to negative 7. Right hand side, okay, we got 3 on 2x, right, times negative 2 minus 4. Okay. 3 on 2 times negative 2 is negative 3. Right, and that equals negative 7. So left hand side equals right hand side. Okay, therefore the equation is correct. Okay. All right, and that's a good way to check to make sure have we got the right equation. Get those marks if they're on offer.